Hello everyone, how to solve this problem for the values of k if we have square root of k plus 1 is equals to square root of k, and we solve this problem for all the values of k. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further, we solve this problem for two methods. I hope so you like both of these two methods. But if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move towards the solution of this problem from first method. So the reason of solving this question from first method is that if in your exam the question statement is that you need to find the values of k, so or in other words you need to find the roots of this equation, in that case you can just solve this problem from first method. But if in your exam the question statement is that you just determine the solution set of this problem, in that case you just move directly towards our second method. But both of these two methods are valid to solve these types of questions. And now here we move toward the solution of this problem from first method, and here in the first method we take squaring on both of the sides, and when we apply squaring on both of the sides it will be written as square root of k plus 1 whole square is equals to square of square root of k. Okay, and here we need more simplifications, so in the left hand side we use the nice algebraic formula. You know about that. If we have a plus b whole square is equals to a square plus 2 times of ab plus b square, and you see here this term is our a and this term is our b, and after applying this formula it will be written as in this form. So we have first we have a square, here our a is square root of k square plus 2 times of square root of square root of k into 1 plus 1 square equals to this 2 and square root are cancelled out by each other, and we get here k only. So here again this 2 and this square root are gone, and we get here k plus this is 2 times of square root of k, and plus this is 1 square becomes 1 is equals to k. So here our target is to find the values of k. So for this we move all the values other than the square root of k from right hand side. Okay, so this is 2 times of square root of k is equals to this is positive k. When we move it into the right hand side it will become negative k, and this is plus 1 becomes minus 1. And now you see here this is negative k and positive k are cancelled out by each other, and we get in the left hand side is 2 times of square root of k is equals to this is minus 1. So here our target is to find the values of k. For this we need to remove this square root sign from left hand side. So for this we again take squaring on both of the sides. So when we apply squaring on both of the sides, and here we can apply the square separately on both of these two values, and it will becomes 2 square into square root of k, and its whole square is equals to minus 1 square becomes plus 1. And now you see here this 2 square becomes 4, this 2 and square root are cancelled out by each other, and we get here k is equals to 1. So here our target is to get the values of k. For this we divide both of the sides by 4 in order to remove this 4 from left hand side. So when we divide by 4 it will be written as in this form. This 4 and this 4 are cancelled out by each other, and we get here k is equals to 1 divided by 4. So here this is the only one root of the given equation which we get here. And now further in the next step we need to verify that is this value of k be the solution of the given equation, or is this value of k be the extraneous root. So for verification of this root we need to copy down given question statement. Here it is square root of k plus 1 is equals to square root of k. So here we substitute this value of k on both of the sides and we check its behavior. So it will be written as square root of 1 divided by 4 plus 1 is equals to square root of 1 divided by 4. So here when we apply the square root on both of these two terms, so you see here square root of 1 becomes 1 and square root of 4 becomes 2. plus 1 is equals to, again square root of 1 becomes 1 and square root of 4 becomes here 2. So here we need to take the LCM into the left hand side, and we have its LCM becomes 2. So this 2 and 2 are gone, and we get here 1 plus 2 is equals to 1 divided by 2. So in the next step, we have 2 plus 1. This 2 plus 1 becomes here 3 divided by 2 is equals to 1 divided by 2. So here you see that both of the sides are not equal, because 3 over 2 is not equals to 1 over 2 in general, or in other words we say that it is not possible case. Okay, it is not possible that 3 over 2 is equals to uh, 1 over 2. So here this means that the value of k is not satisfied our given question statement. So we call that k equals to 1 over 4 be the extraneous root of the given equation. Okay, so this is the extraneous root. It means that we cannot get any other value of k which is satisfied our given question statement. So we call that this question has no real solution or no solution. Okay, this question has no real or complex solution. So this is the final answer of first method, and now here we again solve this problem from second method. So here our second method is a very straightforward method. So in this method we just quickly get the roots of this equation. So for this we need to copy down given question statement here. Given question statement is square root of k plus 1 is equals to square root of k. This is our given question statement, and here we just quickly get the roots of this equation. So first we move square root of k to the right hand side, and it will be written as 1 is equals to square root of k minus square root of k. So these two are cancelled out by each other, and we get here 1 is equals to 0. And here again you see that 1 is not equal to 0 in general, or in other words we say that it is not possible case. Okay, it is not possible that 1 equals to 0. So this means that here in the second method we cannot get any value of k which is satisfied our given question statement. So we call that this question has no solution. Okay, so this is the final conclusion about the solution set of this problem, and this is the our final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.